Hey guys, Miss Nguyen here with our reflections notes. Let's go ahead and get started. A reflection is one of the transformations that we're doing this year. It's the second one. We just did translations. Now we're doing reflections. And a reflection is a very different kind of transformation from a translation. Okay? A reflection, when you think about the word reflection, most of you think about, mirrors, right? Well, when you look at yourself in the mirror, that's not really what you look like, right? Because the image is flipped. Same thing when you take a selfie with like the front camera, the image is flipped. Okay, so a reflection flips a figure across a line of reflection. Line of reflection. Such as the x-axis or y-axis. Okay, so in 8th grade math, we're only going to be flipping across the x-axis or the y-axis. Okay, the image is a mirror image of the pre-image. It's a lot of the word image. Basically to say that it's flipped, right? So when you are wearing a shirt that says Nike on it and you look in the mirror, it doesn't say Nike in your reflection, right? Because everything's been flipped. Okay. So since we are dealing with two different types of reflection, I have two examples to show you here. Okay, in the first one, this is our pre-image. We know this because it doesn't have any prime marks on the letters. When you have prime marks on the letters, that's the image. That's the after. The pre-image is the before, right? So this is the image. Okay, so that means it started here and it went here, flipped this way. When it did that, it crossed the y-axis. Remember, the y-axis goes up and down. So it crossed the y-axis. So this first picture here is a reflection across the y-axis. Okay. Second picture, again, our pre-image is the one that doesn't have any apostrophes. So here's our pre-image. This is our image. Well, this time it flipped from top to bottom, flipped this way. Okay? So when it did that, it crossed the x-axis. X-axis goes side to side. It crosses over the x-axis when it flips, so that means that this is a reflection across the x-axis. Okay? Now here's an important thing to consider. Each vertex, aka point, or we can also think of it as a corner, each vertex of the image keeps the same distance from the line of reflection as that of the pre-image, right? Well, what does that mean? That means that if you pick any, let's look at the first picture. If you pick this point here, point B here, the line of reflection is the y-axis, okay? So how far away is this point from the y-axis? Let's count. 1, 2, 3, 4 away. So that means that B prime has to be the same distance away. So here's the y-axis. We count 4 away. 1. Oh, my pen. Come on, pen. 1, 2, 3, 4. That's why it's here. Same distance away. We can do the same thing over here on the other picture. So here's point A. Point A is 2 away from the x-axis. Well, A prime is also 2 away from the x-axis, the A-axis, the x-axis. Okay? So when you flip the figure over, its distance from the line of reflection should still be the same on the image versus the pre-image. That's why if you have a mirror and you touch the mirror with your finger and you look at your finger and the reflection, there should be no gap. It'll look like there's just two fingers touching each other, right? But if you're further away, then it'll seem like there's more of a gap because the distance between you and the mirror is the difference, or is the same distance as your reflection from the mirror, because the mirror is your line of reflection there. Okay? So, you probably already noticed this by looking at the picture, but reflections cause the orientation of the figure and the vertices to change. Okay? So this is more obvious in this picture, the second one, right? But when we flip this, it's pointing in a different direction. The figure is no longer pointing the same way as before. B used to be pointing straight up. After we flip it, B is pointing straight down. So the orientation of the figure has changed, right? Remember, orientation of the vertices is looking at the order of the letters on the corner. So originally we have A, B, C, right? If we go clockwise, A, B, C. Well, after we flip it, it's not A, B, C anymore. You pick a point and go clockwise. So we start with A prime, C prime, B prime. So it went from ABC to ACB. Okay? And so that means that the orientation of the vertices has changed. So this is a lot more interesting than translations where nothing really changed much. Now here's a question. Do reflections preserve congruence? Okay, that is to say, are the pre-image and the image congruent or not? This is a little bit of a trick question because you might look at this and think, oh, they look different. But the answer is yes. Okay, because the size and shape did not change. Size and shape did not change. Okay, something to think about. Let me show you. Okay, sorry about that. If you have this hand sanitizer bottle and we flip it, so let's pretend that we're flipping it across the x-axis and we flip it down. Is this still a bottle of hand sanitizer? Yes. Just because I flipped it doesn't mean that the shape actually changed. It's still the same shape. It's still the same thing. It's just if I flip it this way, flip it that way, doesn't matter. It's still a bottle of hand sanitizer. So even though the orientation has changed, the actual shape is still the same. So yes, it preserves congruence because the size and shape did not change. Okay? Well, so now we get to the meat and potatoes, the algebraic rules for reflections. Well, unlike with translations, we don't have to count or do anything like that. There's just two that we have to remember. Okay? First one is when we reflect across the x-axis, and the second one is when we reflect across the y-axis. Okay? So you'll see, when we reflect across the x-axis, if the original point is xy, it becomes x negative y. When we flip across the y-axis, the original point is xy, and the new point becomes negative x, comma y. Okay? Here's something important to note. The negative sign does not mean that the number for that coordinate has to be negative. It's not always going to be negative. That negative sign just means that that particular number changes signs. Okay? So for example, let's say you have a number, it's 8, and we're going to flip it, so the 8 has to change signs. Well, if it's positive 8 to begin with, it becomes negative 8. Okay, that's obvious. You put a negative sign in front of it, it becomes negative. But what if our number is originally negative 8? And I'll draw a line here. If our number is originally negative 8, well, we're going to put another negative in front of it, so it becomes negative 8. What happens when we have two negatives in front of each other like that? Or two negatives next to each other like that? They cancel out. This cancels out, so it just becomes regular old positive 8. So this negative in the rule here and here, this just means that if the number is originally positive, it becomes negative. But if the number is already negative, then it just flips and becomes positive. That's all. The number isn't always going to be negative, it's just going to change signs from whatever it started with. Okay? So, when we reflect across the x-axis, the y-coordinate switches signs. You see that in the rule. When you reflect across the x-axis, x stays the same, y changes signs. So that's what it means. Y-coordinate switches signs while the x-coordinate stays the same. But when we're reflecting across the y-axis, then the x-coordinate changes signs while the y-coordinate stays the same. The coordinate that is the opposite of the axis being reflected across is always the one that changes. Or a better way to think about that is, if you're reflecting across the x-axis, the name of the axis, x-axis, that tells you that's the one that's not going to change. So if you're reflecting across the x-axis, x stays the same, y value changes signs. If you're reflecting across the y-axis, the y value stays the same, the x changes signs. Okay, and remember that the original point is always x comma y. So if you're reflecting across the x-axis, that means that the first number will stay the same, and this second number is the one that changes signs. if you're reflecting across the y-axis, then the y, the second number, stays the same. The first number changes signs. Okay, so you're not changing the order or anything. It's just one of them is going to change signs. One of them is going to stay the same. Okay, so now let's look at some practice problems. Okay. Number 1 says, pentagon VWXYZ is shown on the coordinate grid. A student reflected pentagon VWXYZ across the x-axis to create pentagon V', W', X', Y', Z'. What algebraic rule describes this transformation? Well, it tells us we're reflecting across the x-axis, so we actually don't really need this picture. We know that the rule for x-axis is that x stays the same, y changes signs, so the algebraic rule is x comma y, arrow, x, and y changes sign, so it's negative y. Right? Let's look at number 2. Number 2 says, triangle EAT is shown on this coordinate grid. Ms. Nguyen reflected triangle EAT across the axis to create pentagon, this is supposed to be triangle, triangle EAT, or E prime, A prime, T prime, to make up for the fact that she didn't eat breakfast. So sad, so sad. So what algebraic rule describes this transformation? Well, this time we're going across the y-axis. Okay, so this part of the rule always stays the same no matter what transformation we're doing. This first part with the x, y, and the arrow, it's always going to be the same. And it becomes, okay, y-axis, so x changes signs, y stays the same. All right. Let's look at number 3. Let's review a little bit here, okay? It says a figure is transformed so that it goes from quadrant 1 to quadrant 4. It has been reflected across the blank axis, so we need to figure this out, okay? Well, hopefully you learned this last year, but if not, quadrants, we want to label them like a C. So where the C starts, that's number 1, and then we just keep following it counterclockwise to label the other 3 quadrants like this. And I'll put this in plain numbers too. This is 1, 2, 3, 4, but you really need to get used to those Roman numerals, because when they talk about quadrants, for some reason, it's always in Roman numerals. Okay, so the question says it starts in quadrant 1. I'm just going to draw a star to pretend like this is our figure. Quadrant 1, and then it moves into quadrant 4. That means it flipped this way. So when it flips this way, it crosses which axis? The x-axis. Okay. So you can try number 4 on your own. You can mark the quadrant same way and then see it went from quadrant 4 to 3. So which axis did it cross? I'll leave that to you. Okay, last but certainly not least, okay, number 5. It says quadrilateral ABCD has vertices A, -1, 2, B, -1, 5, C, 4, 6, and D, 4, 2, and is reflected across the y-axis to create quadrilateral A prime, B prime, C prime, D prime. So they want to know what are the coordinates for the vertices of the image. So we have the pre-image points. We're going to apply the rule to get what the new points, the image points, are going to be. Okay, so we're reflecting across the y-axis. So that means, y-axis means the rule is going to be, if we start out with xy, x is going to change signs and y stays the same. That is the rule for reflecting across the y-axis. So this rule tells us exactly what to do with each point. Something I like to do as a strategy is, since we know that the x values are going to be the one that switch signs, I'm just going to circle all of the x's. Remember, x is the first number, so I'm going to circle all of those, and that tells me right there, okay, these are the values that are going to change signs. So when I write these coordinates, those ones that I circled change signs, and the one that's not circled, we just leave it alone. Let it rest. So for A becoming A prime, -1 becomes +1, 2 stays the same. For B prime, again we have -1, so it becomes +1, 5 stays the same. For C to C prime, we have a +4 for x, so it becomes -4, and 6 stays the same. Finally, for D prime, once again we have 4, so this becomes -4, and 2 stays the same. There we have it. That's all we have to do. No adding, subtracting, nothing special. Just switch signs. Okay, so I want you to do number 6 on your own with quadrilateral Doge. reflecting across the x-axis, same steps. Okay? You got this. Okay, last we have this vertices only practice. Okay? So I'm going to do the first table with you so you can kind of see how we're supposed to go, and then you're going to do number 8 by yourself. Okay? So this is kind of just more of what we just did with the vertices, because this is really important vertices practice. Okay? So we have the pre-image coordinates in the first column. Alright, the second column says we're going to reflect across the x-axis. When we reflect across the x-axis, x stays the same and y changes sign. So we're going to do that to each of these points. Okay, so P prime. X stays the same. X is 1. And you know, you can label these if it's hard for you to remember sometimes. No shame. So 1 is going to stay the same. 2 changes signs. Okay, A prime. -5 stays the same. 6 becomes -6. W prime. 2 stays the same. -7 switches signs, so now it becomes +7. And finally, N prime. X stays the same, so this is -5 stays the same, and this 9 becomes a -9. Okay? Once it clicks, once you get it, you just change signs, easy peasy. Last column is being reflected across the y-axis. So this time the rule, xy, x changes signs, y stays the same when we reflect across the y-axis. Okay, whichever letter is inside of the name of the axis, that's the one that stays the same. That's how you want to think about it. Okay, so we're going to use the pre-image coordinates once again. So we're not transforming these. We're not doing that. We're using the original coordinates. Oops. Okay, so P prime again. Okay, x is going to change, so +1 becomes -1, and 2 stays the same. A prime, -5 changes signs, becomes +5, 6 stays the same. W prime, 2 becomes -2, right, to switch signs, -7 stays the same. And finally, N prime again. -5 is going to change signs to become +5, and then the 9 stays the same. Okay, and that's about it for reflections. Okay, hopefully from this you understand what to do, and you can do this last table on your own. If you have any troubles, of course, let me know. But I think that should just about do it. If you haven't yet, please go on IXL and do the practice. The code for this reflections practice is 5UM. It's not an S, it's a 5. 5UM. Okay? And make sure you go and get an 80 in that if you haven't already. Okay? For full credit on that. Okay? So that's about it. I will see you in class. Bye.